Hello, this video is just going to quickly go over the solutions to this warm-up. The solutions are already here, so you can kind of check your work as you go, but I just wanted to highlight a few things for each of these parts of the problem. So for questions 1 and 2, what you're asked to do is just either list the characteristics or you're asked to sketch the graph based on the characteristics. So here we have our standard questions of degree, what the number of real roots are, and what the number of complex roots are. And so the degree is like the number of directions it goes. So down is 1, 2, 3, 4, 5, 6, 7. That's how you know it's 7. You also know it's odd because your arrows or your endpoints are going in different directions. Real roots is just the number of times it crosses the x-axis. Just the number of times. So it's just literally the number of x-intercepts, so that's 4. Remember, complex roots are any time you have a parabola which is opening away from the x-axis. So therefore, this gives you 2 complex roots, even though it's in one location. If we move over to the other one, we know this degree would have to be even because your arrows are pointing or the endpoints are pointing in the same direction. There are 3 x-intercepts, so our real roots are 3. The number of complex roots are just the number of parabolas which open away, not towards, like this one here at the top is opening toward. This one is opening away. So there's a total of 4 complex roots. Your complex roots will always be even because they always come in pairs. Now for question 2, A and B, you're asked to sketch a graph. So there's lots and lots of different ways that you could go about sketching a graph. Here we have 4 x-intercepts, so you know that that's going to have 4 different places it crosses. One of these places you need to have it go so it's opening away, and the number of real roots is 4. The degree is 7. So if you add these up, 4 and 2, that makes 6, of course. We're missing 1 to get to a degree of 7. So one of these x-intercepts has to be a double root. And so as I sketch a possible graph, it doesn't really matter. So if you can come down through here, come through here, I'm going to bounce off this one. I have to have a parabola which opens away and then cross back through. So that's just an example of something that would possibly work. I'll zoom in just a touch so you can see 4 x-intercepts, 2 complex roots, 1, 2, 3, 4, 5, 6, 7 as your degree. As we move over to this one, this has a degree of 10, and real roots is 3, complex roots is 4. So 2 locations has to have a parabola opening away. I have to have 3 x-intercepts, so I'm just picking 3 random places. As you can see then, so 3 plus 4 is only 10. These 3 real roots has to give me a total of 6 towards this degree in order to get 6 plus 4. So all 3 of these need to either be double, and I believe that's really our only option because you could have a triple root. I guess we could have a triple root, a double root, and then a single root. So we could draw it that way. So you have a single root, and then you have a double root, and then a triple root. So now there we have it. The next few problems, you're asked to do either your synthetic division or Polydoku. Now this first one's actually pretty complex, and so that's why I wanted to make sure to have this video ready for you so you can see it. It states that you want to divide this polynomial by both of these factors. Now, using synthetic division, all you have to do is just pick one of them. So pick one of your x-intercepts to go first. So -5 or 1. Now you can see that I chose to go with -5. It does not matter. You could have chosen 1 first up here and then done -5 afterwards. And so if you do your synthetic division, you list your coefficients, you do your drop down and your multiply and add all the way throughout, you see that you get a 0. That's good, and so that's what this statement is over here. If you divide this original polynomial by x plus 5, you end up with this cubic polynomial. And you can go again. You've got another factor that you know, so we know that 1 can be factored out of that. And so you list your coefficients, drop down, multiply, and add, and you get 0 again. Very good. And so now you have these 2 factors plus what's left, which you could use your quadratic formula to get your 2 complex roots in this scenario, and our 2 real roots, which we knew because these were already our factors. Question 4. The reason I want to go over this one is because you have a 5x in front, and so that's why it's a great idea to use Polydoku as an option when your factor has a slope of something other than 1. So you do your Polydoku, and then you fill in everything from starting with your 10x cubed, and you work from there. 2x squared plus 7x plus 6 has these two roots, -2 and -3 halves from your quadratic formula, and -1/5 is your root, not -1, of course, because you have to set 5x plus 1 equal to 0. And finally, this last one, you have 25x cubed here, and a factor of 5x plus 3. Polydoku is a great way to go about it, not use synthetic division. Trust me, it's a lot easier if you do Polydoku for this when it's a slope other than 1 out front. And so you do your Polydoku work again, straight through. 5x squared plus 27x plus 10 is what's left. That gives you these two roots. They're both real, so therefore all three of them are real, and your third root is -3/5. The rest of this worksheet is based upon the presentation that's coming up forward in Polynomials.5B and C. So good luck.